Section 1. Introduction: Ensuring software stability through regression testing. Regression testing is an essential aspect of software quality assurance that focuses on ensuring software stability as new features are added or modifications are made. It involves retesting previously tested software components to ensure that changes have not introduced new defects or regressions. In essence, regression testing is like a safety net that catches unintended consequences before they impact users. As software evolves, it undergoes numerous changes, from bug fixes and new feature additions to performance improvements. Each change, while intended to enhance the software, can potentially introduce new issues or disrupt existing functionalities. Regression testing addresses this risk by systematically verifying that changes have not negatively impacted the software's existing features and functionality. By detecting and addressing regressions early in the development cycle, organizations can avoid costly rework, improve customer satisfaction, and maintain a positive brand reputation. Section 2. The purpose of regression testing: safeguarding against unintended consequences. Regression testing ensures that new code changes have not adversely affected existing functionality. When developers modify software, they aim to improve it without introducing new issues. However, these changes can inadvertently create unintended consequences, leading to regressions. Regressions are defects that resurface in previously working software components after changes have been made. These regressions can manifest in various ways, such as broken features, performance degradation, or unexpected behavior. The primary purpose of regression testing is to detect these regressions early in the development process, allowing teams to address them promptly and prevent them from reaching end users. By retesting previously tested areas of the software, regression testing acts as a safety net, catching any unintended consequences of code changes and ensuring that the software remains stable and functional. This confidence is especially important when releasing new versions of software or deploying updates to production environments. Section 3. When to execute regression testing: strategic timing for optimal results. Regression testing is an ongoing process that should be integrated into various stages of the software development lifecycle. Determining the optimal times to execute regression tests is crucial for maximizing their effectiveness and efficiency. Here are some key instances when regression testing should be performed. After code changes. Whenever new code is added or existing code is modified, regression testing should be conducted to ensure that the changes have not introduced any regressions. This includes bug fixes, feature enhancements, performance optimizations, and any other code modifications. After bug fixes. While bug fixes aim to resolve specific issues, they can sometimes inadvertently introduce new problems or resurface old ones. Before major releases. Prior to deploying a major software release, a comprehensive regression test suite should be executed to ensure that all critical functionalities are working as expected. During maintenance phases. Even after software has been released, regression testing remains important during maintenance phases. Section 4. Defining the scope of regression testing: balancing thoroughness and efficiency. Defining the scope of regression testing involves determining which parts of the software to test and how extensively to test them. The goal is to strike a balance between thoroughness, ensuring that critical areas are covered, and efficiency, avoiding unnecessary testing that could delay releases. Factors to consider when defining the scope include impact of changes. The extent of regression testing should be proportional to the impact of the code changes. Significant changes, such as those affecting core functionalities or introducing new features, warrant more comprehensive testing than minor bug fixes or cosmetic updates. Criticality of functionality. Areas of the software that are critical to its core functionality or are heavily used by customers should be prioritized for regression testing. Available resources. The scope of regression testing may also be influenced by available resources, such as time, budget, and testing infrastructure. Risk assessment. Conducting a risk assessment can help identify areas of the software that are more prone to regressions. Section 5. Test case, selection and execution. A systematic approach to regression testing. Selecting the right test cases and executing them effectively are crucial steps in regression testing. The goal is to maximize test coverage while minimizing the time and effort required. Here's a systematic approach to test case selection and execution. Prioritize test cases. Not all test cases are created equal. Prioritize test cases that cover critical functionalities, areas with frequent code changes, and those with a history of defects. Focus on high-priority test cases first to ensure that essential features are thoroughly tested. Categorize test cases. Categorizing test cases based on functionality, risk level, or impact can help streamline the selection process. Leverage automation. Automate repetitive and time-consuming test cases to improve efficiency and free up testers to focus on more complex scenarios. Maintain and update test cases. Regression test suites should be living documents that evolve alongside the software. Section 6. Effective defect management in regression testing. Identifying, reporting, and resolving issues. Effective defect management is crucial for maximizing the value of regression testing. When defects are identified during regression testing, a systematic process for reporting, tracking, and resolving them is essential to ensure that issues are addressed promptly and effectively. Here are key steps in effective defect management. Clear defect reporting. Provide detailed information about the defect, including steps to reproduce it, expected behavior, and actual behavior. Include screenshots, error messages, and any other relevant details that can help developers understand and diagnose the issue. Defect tracking system. Utilize a defect tracking system to log, track, and manage defects throughout their lifecycle. This allows for efficient communication and collaboration among testers, developers, and other stakeholders involved in resolving issues. Prioritize and triage defects. Not all defects are created equal. Root cause analysis. Encourage developers to perform root cause analysis to identify the underlying reason for the defect. Section 7. Regression testing in Agile and DevOps. Embracing continuous testing for faster delivery. In today's software development landscape, where Agile and DevOps methodologies reign supreme, the need for rapid iteration and continuous delivery is paramount. Regression testing plays a critical role in ensuring that these accelerated development cycles do not compromise software quality. Agile methodologies emphasize iterative development, frequent releases, and continuous feedback. This approach necessitates a shift from traditional phase-based testing to continuous testing throughout the development lifecycle. Regression testing, in this context, becomes an ongoing activity rather than a one-time event. To effectively integrate regression testing into Agile and DevOps environments, organizations should embrace test automation. Section 8. Regression testing in action, real-world examples of its critical role. The importance of regression testing is best illustrated through real-world examples, where it has proven instrumental in preventing software failures and ensuring quality. Here are a few compelling cases. An e-commerce platform released an update to improve its checkout process, aiming to reduce cart abandonment rates. However, the update inadvertently caused issues with the payment gateway integration, resulting in failed transactions. Regression testing would have detected this issue before deployment, preventing financial losses and customer frustration. A financial trading application underwent a performance optimization to reduce latency during peak trading hours. While the optimization improved speed, it introduced a critical error in the order execution module. Regression testing, with a focus on performance and critical functionalities, would have identified this error, preventing potential financial losses for traders. Section 9. Tools and techniques for efficient regression testing, leveraging automation and best practices. Efficient regression testing requires leveraging the right tools and techniques to streamline processes and maximize test coverage. Automation plays a key role in achieving efficiency, while adhering to best practices ensures effectiveness. Selecting the appropriate test automation tools is crucial for efficient regression testing. Factors to consider include the technology used to develop the software, the complexity of the application, and the skills of the testing team. Effective test data management is essential for ensuring the accuracy and reliability of regression tests. This involves creating, managing, and maintaining test datasets that accurately reflect real-world scenarios. Integrating regression tests into the CI/CD pipeline ensures that tests are run automatically whenever code changes are made and deployed. Prioritize test cases based on the risk associated with different areas of the software. Section 10. Benefits of regression testing: enhanced software quality and reduced risks. Regression testing offers numerous benefits that directly contribute to enhanced software quality, reduced development costs, and improved customer satisfaction. By investing in a robust regression testing strategy, organizations can reap the following advantages. Regression testing ensures that software remains stable and functional as new features are added or changes are made. By identifying and addressing defects early in the development cycle, regression testing helps prevent costly rework and bug fixes later in the process. High-quality software that performs reliably and as expected leads to increased customer satisfaction. Regression testing helps ensure that software meets these expectations, resulting in happier customers and a positive brand reputation. By catching regressions early, it prevents the accumulation of technical debt, making it simpler to modify and enhance the software in the future. Section 11. Conclusion: regression testing, a cornerstone of software quality assurance. Regression testing stands as a cornerstone of effective software quality assurance, playing an indispensable role in delivering high-quality software that meets user expectations and business requirements. By verifying that code changes have not adversely affected existing functionalities, regression testing provides a safety net that catches unintended consequences before they reach end users. By embracing regression testing as an integral part of the software development lifecycle, organizations can deliver software that is reliable, stable, and aligned with user needs.